After having looked at orbital speed and period of revolution of a satellite, this video we will try to understand what is a geostationary satellite. So let us look at this particular diagram. Let us say this is the this is Earth, right, which has got radius RE, right, and there is a satellite which is revolving very close to the surface of the Earth. So this is a satellite which is revolving over here. Now, the time period of revolution of the Earth is 24 hours. So time period for Earth is 24 hours. That means the Earth revolves around its own orbit, own axis in 24 hours. Right? Let us say the satellite which is revolving also has the time period of 24 hours. Right? Then what would happen? In that case, what will happen is that if there's a person on the surface of the Earth over here, or let us say here, right? So he will see the satellite overhead, right? He'll see the satellite over here. Now, he is rotating at a rate of the time period of its revolution is 24 hours. So he's rotating at a one particular speed, and the satellite is also having the same time period, 24 hours. So the angular speed of the satellite is also going to remain same. So what will happen is when this particular person, because of the revolution of the Earth, moves out, right, or moves forward, the satellite also moves forward, and therefore this person will continuously see the satellite, right? And we can say that, you know, it would appear stationary on the Earth's equator, right? So if the person is standing over here, he'll see the satellite over here. When it reaches over here, he'll see the satellite over here. When it reaches over here, he'll see the satellite over here. And therefore, to this person, this particular satellite will appear stationary because their relative speed is zero, right? And such a satellite is known as a geostationary satellite, right? It is used for various purposes. It is used to reflect TV signals and telecast TV programs from one part of the world to another. So I hope you understood what a geostationary satellite is. Now, in order to calculate the height of a geostationary satellite, we will use the expression for period of revolution of a satellite at a height h above the surface of the Earth. Right? The expression that we had got was t is equal to 2 pi square root of re plus h whole cube upon g re square. Right? Now, time period for this particular satellite is 24 hours because we are talking of a geostationary satellite. So t is 24 hours. So I can take the value of t as 24 hours and calculate h from this. So what do I get over here? So t square is equal to 4 pi square re plus h whole cube upon g re. Okay. And therefore I can get re plus h whole cube is equal to g re t square upon 4 pi square. And now I know all the values. Re is equal to, the value of Re can be taken as 6.37 into 10 raised to 6 meter. Right? G is equal to 9.8 meter per second square. T is 24 hours. So I can convert that into seconds. I'll get 86400 seconds over here, and value of pi is known. So I know everything over here. I know Re. If I do this particular calculation, I'll get Re plus h is equal to 42,200 kilometer. Right? Please know that this is kilometer, and therefore the value of h I'll get is, the radius of the Earth is approximately 6370 kilometers. So 4220 minus 6370 kilometers. So h will be equal to 35,830 kilometer approximately. So I got h as 35,830 kilometers. What this means is that for a satellite to be geostationary, that means for a satellite to appear stationary, it must be placed in an orbit around the Earth at a height of 35830 kilometer. So this should be placed. So this particular height, let me come back to figure over here. This particular height from the surface of the Earth, this particular height, this has to be 35,830 kilometers, right? Then it will appear stationary, and this is called the parking orbit, right? 35830 kilometers. So if this is 35830 kilometers, this particular orbit is called a parking orbit. And let us also look at V0, right? Now V0 we know is 2 pi Re plus h upon t, right? So for a geostationary satellite, t is to be taken as 24 hours, right? Re and h are known. So if I put these values over here, right, 2 pi into Re plus h, I will have obtained as 42,200 42,200 kilometer, right? Upon t is 24 hour, so I'll get approximately 110442 kilometer per hour, v0. Right? So this is the orbital speed of the satellite, of a geostationary satellite. Okay, let us very quickly conclude what we have discussed in this particular video. What we have said is, for a geostationary satellite, h, right, h has to be approximately 35,000 or say 36,000 kilometers, right, and its orbital speed has to be 11,042 kilometer per hour for it to appear stationary to an observer on the surface of the Earth, right? Thank you. I hope this has helped you understand geostationary satellite and the values that we obtained for them.